Hello viewers, in today's class we are going to discuss one important problem from Rolle's theorem, right? And Rolle's theorem is an important theorem in differential calculus, and this is a mean value theorem. And let us see the problem. Here we have to discuss or verify Rolle's theorem for f of x is equal to sin x plus cos x minus 1 in this interval, that is from 0 to pi by 2, right? So let us solve this problem, but before solving this problem let us quickly see the statement of Rolle's theorem, right? So suppose we have a function, say y is equal to f of x defined on some interval a comma b, right? So this is the domain of this function, and if we have the conditions, that is, the first condition is that this function fx is continuous, right? If this function is continuous in the interval a comma b, and this function is derivable, that is f prime of x exists for this function in the open interval a comma b, and the third condition is that f of a is equal to f of b, right? So the Rolle's theorem says that if we have a function y is equal to f of x defined in this interval, and f of x satisfies these three conditions. The first one is fx should be continuous in this closed interval a comma b. The derivative of f of x must exist in this open interval a comma b, and the value of the function at these two endpoints of this interval are equal. Then Rolle's theorem says that there must exist some point c between a and b. There must be at least one point, right, between a comma b, such that f prime of c is equal to 0, right? So this line suggests that the derivative of the function at this point x is equal to c must be equal to 0, right? That is, the tangent must be parallel to the x-axis, right? Okay, so this is the statement of Rolle's theorem. Now let us apply this theorem to this function. So now here we see that this function is a combination of continuous functions, right? See, sin x is continuous function in this interval 0 to pi by 2. Cosine function is also a continuous function in this interval 0 to pi by 2, and 1 being the constant function, right? So fx is a sum of the continuous functions, so therefore f of x is continuous, right? So the first condition is satisfied, that is, f of x is a continuous function in this interval, that is 0 to pi by 2, right? Okay, the second one is that the derivative of f of x must exist, right? So if we find the derivative of f of x, then we have f prime of x is equal to the derivative of sin x is cos x, the derivative of cos x is minus sin x, and 1 being the constant, the derivative of 1 is 0. So here we have minus 0, that is cos x minus sin x, right? And we can easily see that the derivative here it exists in the interval that is 0 to pi by 2, right? So f prime of x is defined for all values for x which belongs to 0 to pi by 2, right? And the third condition is that fa must be equal to f of b, right? So what we will do, we'll first find f of a. So here a is 0 and b is pi by 2, right? So f of a is f of 0. So f of 0 is sine 0. Here we'll take x is equal to 0. Then we have cos of 0 minus 1. So this is 0 plus 1 minus 1. Sine 0 is 0, cos 0 is 1, minus 1. So this is 0, right? and f of b is f of pi by 2, right? And this is again we can take x is equal to pi by 2 over here. So we have sine pi by 2 plus cos pi by 2 minus 1. So sine pi by 2 is 1, cos pi by 2 is 0, and this is minus 1. So 1 minus 1 is 0, right? So we see that f of 0 is 0 and f of pi by 2 is 0. So f of 0 is equal to f of pi by 2, right? So the three conditions of Rolle's theorem are satisfied by this function in this interval. So once these three conditions are satisfied, Rolle's theorem says that between 0 and pi by 2, between 0 and pi by 2, there must exist at least one point at which the derivative of this function at that point, say c, is equal to 0. So what we will do, here we have f prime of x is equal to cos x minus sin x. So f prime of c must be equal to 0 and f prime of c is equal to cos c minus sin c, right? So here we'll take x is equal to c, right? So we have cos c minus sin c is equal to 0. So cos c is equal to sin c, right? And again here we have our trigonometric equation and we have to solve it for c. Now cos c is equal to sin c, which can also be written as 1 is equal to sin c over cos c, and we can write sin c over cos c is equal to tan c, right? Tan c is equal to 1, and the value of c for which tan of c is equal to 1 is tan of pi by 4, that is 45 degrees, right? So we have c is equal to pi by 4, that is 45 degrees, which belongs to this interval, that is 0 to pi by 2, right? So here c is equal to pi by 4, and pi by 4 obviously lies between 0 and pi by 2, right? So this is how we can verify Rolle's theorem for this function in this interval, that is from 0 to pi by 2.